Hello, we are now live and I'm going to discuss about the differential equation application, the first application that we're going to take up today. And this application was included in your midterm exam. And sad to say that we cannot meet because of the typhoon. And I do not know about the schedule. You'll be informed when you're going to take the exam. Supposed to be starting tomorrow, but we're just waiting for the announcement. Okay, let's go to our main business, which is the learning of the first DE application we're going to take up, and this is growth and decay. I'm going to share my screen now so you can see what I am doing and what I'm going to discuss with you. There's a lot of intro. Hello, Nico. All right. Can you see my screen? Can you please comment here, Mr. Shading, if you can see my screen? It says here online lecture, growth and decay. Can you see it? All right. So what is about growth and decay? For growth is always positive because it connotes development. You have to be in my YouTube channel, Wonderful Mommy Devs, and please click the link that Mr. Shading sent in the Facebook. So growth connotes development. It connotes increase. It connotes any positive improvement. Of course, improvement is always positive, and so on. So if you read the word growth, increase, development, improvement, they all connote positive positive um, positive change, I would say. Okay, now with that, the differential equation that we're going to use for growth would be dp over dt equal to kp. All right, so p is the change in population, because normally we are trying to analyze here improvement of population or whatever. If it's about the improvement of say appearance of a person for time elapsed t, so this is the time, the change in time. The k would be the constant of development, constant of growth, or constant of change for a particular year. And that's it. These are the only variables that we need. Now, that is positive. Why positive? Because your k here, it has a hidden plus. Now, when it comes to decay, what will be the difference of the growth and decay? For decay, it will be, I'll use the same p, dp over dt. The change of population in terms of time or whatever variable you are trying to solve is equal to a minus kp. That's the only difference. There's nothing more to add in here. A very straightforward application of growth and decay. Right. So this is the positive one, and here is the negative. I hope this is clear. Okay. So let's go to an example now. Problem statement. You can read with me. A certain species of bacteria grows in a controlled environment. the growth rate of the bacteria is proportional to its current population. If the initial population of the bacteria is 200 and the growth constant is 0.03, find the population of the bacteria in 5 hours. Right. So it's growth. Okay. I'm going to remove that mean time and I'll just shade it with neon blue so that there will only be, I will also remove this one. There will only be 1, 2, 3 data that you're going to identify. All right. So let's identify the 200 here. The 200 is actually your initial population. Initial population, it says. So that will be 200. Sorry for the wonky thingy. Okay. And the growth constant K is 0.03. The constant is always less than 1. And find the population, so you are required to find for the population after 5 hours. Okay? Or we can put here P of 5 hours. There you go. Therefore, the time that we're going to include in our analysis will be 5 hours. What happened to the pin at this point? It seems like it's gordo. Okay, 5 hours. There you go. So let's split our window so you can see the given that we're going to find and then the solution underneath. Hang on. There. So here's my solution in red. We said that the differential of the population with respect to t, or with respect to time, is Kp, it's positive. So what we're going to do, we have to collect all p's together and others together. So here we have dp over p equal to k dt. How did I do that? So dp over dt is equal to kp. If you're going to multiply everything by dt so that you're going to eliminate the denominator, then the dp over dt on the left side will just be dp, and on the other side it's kp dt. Since we're going to do an integral later, so we have to combine all variables together, we have to divide everything by p. So the p cancels out here, and you will have dp over p equal to k dt. All right. So let's remove all the workings here meantime because I'm limited with space. So I want to use all this later. Okay. Now let's work on this. We know that Ln U is equal to du over u. So if you integrate du over u, you get ln u. So if we're going to integrate dp over p, you get ln p. If you integrate the other side, the k here will be outside because k is constant, and the integral of dt is just simply t plus c because we did an integration. Right. Now, for us to get the particular solution, then we have to raise all the LP and KT and C above E. So the E will be your base. That is to remove the ln, the natural logarithm. So what happens is you're going to raise all this into your variable E. Hang on. It's playing up. There you go. Huh? So it will all become an E raised to LP equal to E raised to KT. Did you understand? Right. And the rule of integration is, or the rule of natural logarithm, I should say, is when the base is E and you have an ln as your power, then the u of ln will be the variable or the expression you put down here. So in my own version of understanding it, this is what I'm going to do. So for you to understand it better, P will be there, and then ln will go here, and E will be there, because we know that ln E is equal to 1, leaving P as the only variable at the left side. And this will be cut into, on the right side of the equation, this can be cut into 2, because we know that x to the n times x to the m is equal to x n plus m. Now, x here will be our base E. So we will have an E to the KT and an E to the C. These are 2 multiplied together. Okay. Now, your E to the C is actually your initial population. E to the C is constant, and the one given here in our problem is POK t is equal to 5. The PO is the one not changing because you have started everything from there. So E to the C will be equal to 200. Okay, let's continue. P, therefore, will be a function of T. So P of T, which is very evident because your E is raised to a variable T. This is constant, and that is constant, and this is the one we're looking for. So it's only T that is the variable in our expression. So we will call it as P of T. And then you have E to the K is 0.03 T. What is our T? 5. And what is our E to the C? It's 200. Okay, so substituting this one, let's put in a different color. P of 5, which is the one we are trying to solve, is E to the 0.03 times 5 times 200. Let's see what we get in here. So you have to use your calculator. All right. What we're going to put in will be the right side of the equation. Let's put in 200 meantime. Can you see that? 200 times in a bracket, I will put in my E, and E is shift ln to the power of 0.03 times times 5, I should say. Okay, and then close bracket. That's all you need to do, nothing more. But you need to set up all these values and then press the equal sign. So you get 232.3669. 232.3669. Because this is bacteria, we can just say 232.37. Okay, so that's the answer. 232.37 bacteria. 232.37 bacteria. Okay. So for the point 37, this is not yet whole bacteria. Maybe point 37 is 37% of the body is being built. So for example, this is the whole bacteria, yeah? If you're going to divide this into four parts, because four part, that would be point 25, point 25, point 25, point 25, point 25. So point 37 could be a bit here, there. So maybe this is how big the bacteria is. At This is how big the big bacteria for it to go up to 233 after 4 hours. Okay, so that's it. That is the uh, growth application for differential equations. Okay, what is the unit here? Of course, 232.37 bacteria. All right. Next, we move on to the decay. Sorry. Right, let's go to the decay. The approach for the decay is the same. It's only that the formula becomes a negative Kp on the other side. Right, here's the question. A specific type of wood experiences decay. So we know that when it's like that, you straight away write the formula. dP over dt is equal to negative Kp, because it's decay at a rate proportional to the amount of undecayed wood remaining. What is this undecayed wood remaining that this question or problem is talking about? So for example, you have you have a log here. Okay, it's decaying. Okay, and this was formerly this big. Okay, when it's a still whole log, but because of rain and shine and whatever wind and temperature change and so on, then a portion of the wood exposed to the sun, maybe this is on a shed example, and the exposed part is the one that is being decayed. Where is it? This bit here, this bit here. Okay, so what happens is you have a remaining part of the wood that you're going to analyze, which is this one. This is the undecayed wood remaining that the problem is telling you. In the question that I'd given in the exam, it's about steel rods. So you're going to find what could be the mass of a steel rod that has not been decayed. So these are the uncorroded steel rod remaining. Now the example I'm giving you is the steel, sorry, it's all about wood naman. Okay. Now let's continue. If the initial mass of the wood is 800 grams, so initial mass, MO, is 800 grams or M sub O, right? And the decay constant, K, is 0.02 per year. What does it mean 0.02 per year? So if you're going to multiply the zero point zero 0.02 to the original mass, then that could be the total amount of mass that is going away each year, because that is the constant rate. That's how do they get the K? Through experimentation, that from the initial mass, they have to weigh it after a year, or they have to weigh it if they're going to make a graph. Maybe they're going to weigh it after 6 months or so, and then when it gets to 1 year, then they get the reduction of weight because some parts of the wood are already gone. And then the next year, if they're going to observe the rate of decay for 3 years, maybe, then they must have a record for 3 years, and the mass for each year will be there, and the change of mass will also be noted, and then they can make a ratio, like whatever is the initial minus the current divided by the current, then that would be the percentage of decrease, or they can change that to decimal, so that will be a decimal form of the constant, not a percentage. Like zero point zero 0.02, that can be 2% per year, right? Now, determine the mass of the wood remaining after 5 years. So what are we going to try? What are we going to find out here? The mass of the wood. So now I'm going to change the P to M, because that is what is mentioned in the problem. M is what we're going to find out. M of 5. That's it. So what shall we do? It's the same approach. The approach would be, hang on, let me just split my window meantime so you can see what is in here. View it and split it. That's it. Okay. Right. So we'll not be using dp, but we'll be using the difference in mass. Over time t is equal to negative km. All right. Put all m's together, so you'll have dm over m is equal to negative k dt, like what we did earlier on. And then dm over m, that will be L and m, equal to L and m, and equal to what did I do here? Let me just make it there. L and m, Ln, that was LP, correct? So we will do the same in here. LMN, L and m, minus K, hang on, sorry for that. It went down. Hey, sorry, A. Hang on. It's playing out now. Hey, what happened? There you go. Right. LMN, LMN, L and M, and then you have negative K dt. Because you want to remove the ln, then you have to raise everything. You have to raise them from E. So E ln m is equal to E to the negative K T. Here, wait. I don't have much space. I can, sorry for the disturbance. Hey, okay. I'll just write very little here. Okay, here. Sorry. Okay. Next thing we have to do is to integrate. There. And my pen is going wonky. There. That's the one I missed. So you have to integrate L and M will be, sorry. I think I lost my track. Wait, I lost my track. I lost my track, sorry, because of the space. If I don't feel comfortable, then everything is distorted. Let's start again. So dm over dt is equal to minus, even the pen is becoming wonky, I didn't know. Right, dm over dt is equal to negative k km. All right, and then put the m's together. It's equal to minus k dt. There you go. And what's next is, it's not even changing. Look at that. Never mind. It's okay. You have to integrate. So the integral of dm over m is ln m equal to negative k t plus c. Right. To remove the ln, you have to raise everything with an e. And on the left side, it becomes ln em equal to e to the negative kt times e to the c. ln e is 1. So m will be equal to e to the negative, what is our k? 0.02. And our t is 5. And e to the c will be the initial value, which is 800. You can also write it as m is equal to 800 e to the negative 0.02 times 5. So m will be equal to, right. So let's calculate 800. Oh, see, even the 800 times our e, shift ln raised to negative. Look, what I'm doing is a negative power 0.02. Hey, again, 0.02. And then you multiply that power by 5. See what we get. Equals. There you go. So it's 723.87. 723.87. What is our unit? That is grams. Was it grams? Does it say grams here? Yes, it does. So 800 grams, sabi. Okay. There you go. There. Okay. So that's all you need to know for the 2 questions that are given in the exam. For the first part of the exam, then that is just multiple choice. But there is a twist because you have to show your workings. All right, back here now. There you go. Okay, so I hope you understood it. There could be a bit of, confusion doon sa second part, but yeah, kasi kulang yung space kanina, but yeah, I hope you understood that bit. You can just go to where I have discussed it. You have to skip that part where I made some made you confused. I mean, all right. So this is all for now. With or without classes, I have already discussed with you the application, and there will be more applications actually of DE. That's just the first one I had discussed with you dahil yan ang nandun sa ating midterm. But when we all come back for the final discussions, then siguro tatlo or apat na examples ang ibibigay natin. Wala namang problema kung direct to the point tayo. So, actually, we can discuss the whole DE sa isang buwan lang eh. Pag yung yun lang na topic ang ano natin, gagawin natin. Pero syempre, kailangan natin mag-sit work, kailangan natin kasi we need that for your grade computations. You need that for your certificate na kayo ay tapos sa DE for this semester. Anyway, I wish you all the luck. You just have to go through it many times. Okay, yung binigay ko na questions. And then that's it. Ifo-forward ko dito yung questions na ginawa ko, okay, sa Facebook. And yun ang i-review nyo. You just have to master it, kalas. Okay? And also, linear, you have to review your linear and you have to review your Bernoullis. For linear, can you remember that? You have the PX, something like that. Yeah? Meron kayong integrating factor. Oh, sige. Mangan pay, ma'am. Sige lang, Eric. O sige, kinapig sa titudo dito yan. Alright. Dahil I will have to do another video for, I think I have to do the EDA. If not, statics ang next ko. Eric, mag-comment ka nga. How is the thingy? How is the explanation? Nakuha nyo yung negative KT tsaka yung positive KT natin? The growth and decay. Eric, naintindihan mo? Paki-pass na lang yung video. Salamat sa inyo na nag-attend. Bye for now. All right. I'm going na. 1, 2, 3. I'll end the stream. Oh, yes. Okay, very good, Eric. I know that you are not only relying on my explanations, you rely on other sources din. So, guys, you have to imitate Eric. Thank you, Eric. Can you Eric, please pass the link. And Mr. Shading, you have to pass the link. Thanks a lot. Bye for now. Take care.